Hello everyone, welcome to CVPR 2025 presentation. This work presents our paper titled Question-Aware Gaussian Experts for Audio-Visual Question Answering, also known as QA-Tiger. QA-Tiger addresses the limitations of existing AVQA methods, particularly their lack of early question integration and coarse handling of temporal dynamics. The first challenge is semantic misalignment between the question and audiovisual features. Most existing models incorporate the question only at the final reasoning step or for frame selection. As a result, they fail to align modality features with the question throughout the pipeline, leading to a loss of question-specific context during reasoning. The second challenge is temporal coarseness. Uniform sampling treats all frames equally and includes irrelevant segments. Top K frame selection improves relevance but ignores temporal continuity, making it unsuitable for fine-grained temporal reasoning tasks. Our goal is twofold. First, to inject question information early in the feature encoding pipeline, and second, to capture question-aligned temporal dynamics continuously rather than relying on discrete frame selection. Our first key idea is to explicitly embed the question into audio and visual modalities from the start. This allows each modality to process features that are semantically aligned with the question, enabling deeper, question-aware reasoning. The second idea is to introduce Gaussian experts that are dynamically activated based on the question. These experts softly attend to question-relevant temporal spans, providing continuous and adaptive focus on important moments in the video. QA-Tiger consists of three main components. First module is question-aware fusion, which injects the question into the modality features early. Second module is temporal integration of Gaussian experts, which models fine-grained temporal dependencies. And finally, we propose question-guided reasoning, which integrates multimodal representations for answer prediction. In this module, we apply self-attention and cross-attention within each modality. We use word-level question embeddings as keys and values in cross-attention, so each modality learns question-aware features. This enables each modality to highlight different aspects of the input depending on the question's semantics. Next, we refine patch-level visual features to better align spatial details with the question. We apply self-attention and cross-attention between the patch tokens and the question-aligned features. This step is especially useful for tasks like counting or localization, where fine spatial information matters. This module captures fine-grained temporal structure using a mixture of experts architecture with Gaussian masks. We first generate question-aware summary features for each modality, using sentence-level question features as the query and cross-attention. Then, we create e-Gaussian distributions per modality, with each expert defined by a learnable center and standard deviation. To ensure that experts cover diverse temporal spans, we apply a disjoint center constraint during initialization and refine them with learnable offsets. Each expert produces a temporal weight over the sequence, and their outputs are combined using routing scores. What's notable is that each modality learns to focus on different segments depending on the question. This allows QA-Tiger to independently control temporal attention for each modality in a question-specific way. In the final stage, we integrate audio and visual features in a question-guided manner. We first average and fuse the two visual representations and apply cross-attention with the question. Then, we fuse this result with the audio feature through another cross-attentions. The resulting multimodal representation is passed through a linear layer and softmax to predict the final answer. QA-Tiger achieves state-of-the-art performance on three AVQA benchmarks: Music AVQA, Music AVQA-R, and Music AVQA version 2. It outperforms previous methods, especially on complex reasoning types such as AV counting, AV localization, and temporal QA. Ablation studies show that adding the question-aware fusion module alone leads to significant improvements. This validates that early integration of question information is critical for effective audiovisual reasoning. In Case 1, attention dynamically shifts between modalities, initially focusing audio attention on the piano due to its sound. As the flute grows dominant, visual attention tracks the ongoing piano play despite reduced audio presence. In Case 2, the module emphasizes visual cues like instrument, right and left for spatial localization, and audio cues like louder to gauge sound intensity, enabling effective multimodal reasoning. The Gaussian Experts module independently enhances performance. Among temporal methods uniform, top K, Gaussian weighting, our MOE-based Gaussian achieves the highest accuracy, confirming the strength of our adaptive temporal modeling. In the first example, QA Tiger counts cellos accurately by examining close-up and full-shot scenes. Uniform sampling can sometimes select frames with all cellos visible, giving correct predictions by chance, but often errors if the frame order changes. The top K method, focusing only on close-up shots, undercounts the actual number. 4 is the flute always playing. Top K selects only frames where the flute is visible and active, overlooking periods of inactivity. QA Tiger addresses this by having audio and visual Gaussians independently attend to different frames, providing balanced insights. Finally, when asked, is the piano playing longer than the violin? Top K's limited frame selection hampers accurate temporal comparisons. Uniform sampling also misses important temporal information. In contrast, QA Tiger adaptively weighs frames across the full sequence, enabling efficient, accurate comparisons. In summary, QA Tiger addresses two major challenges in AVQA. It introduces early, explicit question integration, and it models continuous temporal dynamics using Gaussian experts. Together, these allow the model to reason more effectively and adaptively across modalities. This is our project page, and if you have any questions, you can visit our lab webpage and contact an email. Thank you for your attention.